Hey everyone, we're back with part 4 of this first and third person player controller course. Last time we added in jumping and falling logic and jumping and falling animations to our player. In this part, we'll be going over something that is often overlooked by amateur game developers, which is turning in place, strafing, and walking. This really is a mechanic that you must have if you want to make a publishable game with a 3D player controller, and to be honest, it's one of the more difficult mechanics to do well. Let's head into Unity and get this going. Alright, picking up where we left off, let's go into play mode so I can just describe what the issue is here. So right now, when you turn, our player is simply rotating and matching exactly with our camera look direction. This was nice and easy to set up, but it doesn't look very polished. Ideally, what would happen is we get some kind of turning animation to occur as our player rotates, and not to worry, I got you guys with some free animations from my Patreon. So we're gonna go to my Patreon link in the description and download the zip with the turning animations. Unzip it and we can simply drag the turn left and turn right animations into our project. So I'm really going to be just talking through my general approach here and reasons for doing this as we go, because this really is a pretty hard problem. But first, let's go into our animator and drag each of these turn animations to the locomotion substate machine. We're going to define a transition from any state to each of them. Then for each of the transitions, we'll need a condition, so let's add in a parameter. We'll name it rotation mismatch, and the idea here is that once we exceed some threshold rotation mismatch between our camera and the player, we'll perform a rotation animation. So let's make our transition condition for turn left when the rotation mismatch is less than minus 90 degrees, and for turn right, it'll be when it's greater than plus 90 degrees. Basically, we're triggering a quarter turn or a 90-degree turn here. So let's also make sure to turn off can transition to self for each of these. Let's also define an explicit transition back into locomotion when these animations are done playing. So we automatically will start idling again after they're complete. Open up our player controller script and let's add in a public property named rotation mismatch and another boolean named is rotating to target, and this is going to keep track of our current rotation conditions. Let's also make a few animation related parameters named player model rotation speed and rotate to target time to control basically how quickly our player is going to rotate. Then we'll add in one more member field named rotating to target timer, and this is going to track how far along in the rotation we are in time so that we can stop it when we're done. One more cool little trick I want to show is in the top right here, we can actually just navigate directly to functions. So sometimes I like to use this feature inside of bigger classes like we have now. So we'll head to the late update function. Now, late update isn't very descriptive of what's actually going on here. So why don't we actually just make a new function call? We'll paste this code inside of it and name it update camera rotation. Then we can just call that from late update. Okay, so the thing that we need to change here is our player transforms rotation logic. So let's just talk through a little pseudocode here first. The way we're going to do this is if our rotation mismatch is not within the rotation tolerance, or if our rotate timer is active, then we need to rotate to our target. So let's write that up. If mathf.abs rotation mismatch is greater than 90, where 90 is our rotation mismatch threshold, or our rotating to target timer is greater than 0, that means we need to rotate, so now we'll paste in our old call for rotating the player. There's actually one more condition that's a little more subtle that we need to handle, which is how will we handle rotating if we aren't standing in place or idling? Well, in that case, we just want to immediately rotate to our camera's look direction since we're already playing a locomotion animation, and it's not going to look bad if we just simply rotate then. So we'll say also rotate if we're not idling. To make this a little clearer, let's just get a quick reference named is idling to our current player state, and then we add in if we're not idling, we go ahead and rotate as well. So just to make what's going on here clear, if none of these conditions are met, then we do nothing, meaning we don't rotate at all. Obviously, we don't need this else statement here, so I'm just going to go ahead and delete it, but hopefully that makes it a little more clear what's actually happening. Alright, so we don't want to just immediately snap to the camera direction anymore since that doesn't look realistic. We want to smoothly lerp our player's rotation. So first, let's make a variable named target rotation x, which is actually this exact code here. Then instead, we'll set our player's transform rotations to quaternion.lerp from our current rotation to our target rotation, which is a rotation speed of player model rotation speed times time.delta time. Okay, we programmed in the logic, but we haven't updated our rotation mismatch and is rotating to target parameters. So first, we set is rotating to target to the Boolean expression rotating to target timer is greater than 0. Then we basically just code in a trigger for beginning our rotation. We do that by saying if mathf.abs rotation mismatch is greater than 90f, then we reset our rotating to target timer to our rotate to target time. Then we start counting down to 0 by subtracting off time.delta time each frame. Now at this point, we have our rotation threshold in 2 different places, so let's just create a temp variable for that so we don't need to update it in 2 different places. We'll call this float rotation tolerance and replace it with our 90fs with it. You could argue we could make this like a class member variable so that we could customize it in the editor, but in this case I actually don't want to do that. I just want to hard code it to a value because we've already actually hard coded it in our animator. Alright, so the last thing we need to do is update our rotation mismatch. I'll just do that after our player has rotated each frame down here. So our goal is to get the angle between our camera and the player. It sounds pretty simple, right? Well, it would be, except we want the angle in the XZ plane only, so we gotta do a little extra work. First, get our camera forward projection in the XZ plane by getting the X and Z components and normalizing this. Then we're gonna do a cross product because we need to preserve the sign of this angle, meaning we didn't know if it's negative or positive, as that will trigger different animations. So we say cross product equals vector3.cross our transform forward with our cam forward projected XZ vector. Then we get the sign as a float sign equals mathf.sign, vector3 dot dot the cross product with the transform up direction. And finally, our rotation mismatch is equal to the sign times vector3.angle between our player's forward direction and our camera's forward XZ projection. Yeah, I told you that was going to be a little extra work. Definitely try to understand this math here. You know, if you don't, it's really extremely important to know how to do these signs and cross products and dot products in game dev. Okay, so now we're back in Unity to check out the result of this. So basically, we're gonna slowly rotate, and we see as soon as our camera's look direction is more than 90 degrees different from our player's look direction, we suddenly turn and spin to our camera's direction, exactly what we wanted. So this is great, we're making huge progress, but we need to add in animations now. Alright, open up the player animation script, and first we'll add in our new hash, rotation mismatch hash. Then we simply do animator set float, rotation mismatch hash to our player controller's rotation mismatch. And surprisingly, that's it. You can now see in Unity we're triggering our turn left and turn right animations. A few things now, if you look really closely, the animation is getting cut short. If we look at our animator, you can see we're actually transitioning back into idle before it finishes. This is because the only thing that needs to be true for the transition to occur is for us to be grounded. So obviously it will just immediately transition back into idling. Ideally, we want to rely on our exit transitions here instead, so we need to add in some new conditions for our locomotion transition conditions. First, let's add in a Boolean parameter named isIdling, and we'll add to our current transition conditions isIdling is false. So this condition will be for when we're running or sprinting or walking or something else. Let's make a new condition for the idling is true case. We can simply right-click any state and make a new transition to this. Then let's make isGrounded is true again, and we need to add in one more animator parameter named isRotating to target now. So if we're grounded and we're not currently rotating to our target, so it's false, then we can transition back into idling. We do need to set these values in our animation script though, so let's head back in, add in our isIdling hash and our isRotating to target hash. Then we'll simply update these values in update animation state using our animator's set bool and set float functions for each of them. And for isRotating to target, make sure that you set that to our player controller's Boolean property isRotating to target. That's why we made it public earlier. Okay, now let's try this again. And unfortunately, we have another problem. It's actually that we're just repeatedly transitioning into idle because I forgot to turn off the can transition to self. So make sure you do that for the new state and then we can press play again. Okay, there's one more problem. We're transitioning out of the state before finishing the animation now, so let's take a look at our turn left animation. You can see it's 20 frames long and it's a 30 FPS animation, so it actually only lasts 0.67 seconds or 2/3 of a second. If we go into our character controller's animation settings, you can see our rotate to target time is set to 0.25. So we're actually finishing our rotation way before our animation has visually finished. This is a little clunky, but for now, we can just actually set this to the same time, 0.67, to match our animation's length. Then one final thing, make sure the fixed duration is set for these transitions, and now you can see for both turn left and turn right, it's going through the proper sequence of transitions, and it looks much, much better. I would say at this point, this is probably publishable, but I do want to add in just one more thing here that's going to make it a little more polished. It's a bit hard to notice, but if we trigger a rotation, then we start rotating back the other way, our player just starts kind of slide rotating, and it doesn't look very good. Most big games handle this much better. For example, let's check out the Fortnite player controller. In Fortnite, it uses the same type of rotation logic where after some camera rotation mismatch, the player turns, but it doesn't turn backwards if we try to rotate our camera back the other way. So we want to try to replicate this behavior, but let me also point out one subtle detail. It looks like Fortnite essentially queues up a new rotation if you spin more than 90 degrees in the opposite direction. And to be honest, I don't like how this works. I think it looks a little bit clunky. So what we'll do instead is we'll make it so that our player interrupts our current turn animation with the other turn animation the opposite way if we rotate back super quickly. So that's going to be our goal. Let's code this up in Unity. Navigate to your player controller class and let's add in a member field is rotating clockwise and set it to false. I'm going to go to our update camera rotation function with this tool, and let's break up this if statement to make things a little more clear and less redundant. So we'll make a separate if statement for just the case when we're not idling, paste in these two lines for our player rotation, which basically means that if we're not idling, we're also rotating towards our camera direction. Now we remove the is idling portion from our other if statement and make sure it's an else if statement so both don't run. And we're actually going to be reusing this rotation code, so let's make a separate function named rotate player to target, paste in those two lines and replace it in the if statement. Now we can also replace this in our else if statement. I want to break this code out a little bit further, so let's make a function called update idle rotation and we'll pass in our rotation tolerance as a float. Copy and paste the code from the else if statement and paste it in here. So now this clearly will only be running when we do our idle rotation. We actually want to run this block of code first, so paste it above the rotate player to target, and I'll just comment that this part is when we initiate a new rotation direction. We need to also throw in here is rotating clockwise equal to the Boolean expression rotation mismatch is greater than rotation tolerance. Basically, once we start a rotation, we cache which direction we're turning so that we can later determine if we need to keep rotating or stop rotating to sync up with our animation. Now let's modify our player rotation code. We'll make an if statement, and if we're rotating clockwise and our current rotation mismatch is greater than 0, or if we're rotating counterclockwise and our mismatch is in the counterclockwise direction, that means that we can now rotate. So save this and head back into Unity, and in play mode, you can actually see things still aren't working when we rotate the opposite direction. It's almost like it's not playing the second turn animation when it should. The reason for this is our interruption source setting. Right now, our rotation transitions cannot be interrupted, so if they're not finished playing and we trigger another rotation, we end up doing nothing. So I'm going to basically just assume from now on that everything in our animator is going to be running with interruption source set to next state for all transitions. I'll quickly just kind of cycle through all of our transitions and change that setting around. So let me just fast forward this real quick. And okay, let's do our final check in Unity now. You can see our rotations are working in both directions, and if I quickly rotate the opposite direction, it interrupts our initial rotation and plays our new animation. I can safely say that we are now done with this mechanic. I know that was kind of a beast to add, but this really brings our player controller to a level of polish that a lot of indie game developers just never get to. And one more really exciting thing here, now that our character is lerping its look direction, you should notice that things look a lot smoother and less jittery, and this is a huge improvement over what we had before. The next thing I want to add in is walking. So open up your player controls, and how this is going to work is we'll basically just have a toggle key that turns walk on and off. Add an action named toggle walk, then we'll set the binding to control, save that, and open up your player input script, which should be throwing an error. We're just going to go ahead and implement the missing function like we've seen many times before, and that should just end up right in our input callback region. And yep, there it is. Let's go back up to the top actually and add in a new public property named walk toggled on. And I'm just going to reorganize these booleans so that all the boolean properties are together. Go ahead and navigate to the onToggleWalk function, and this is going to be basically identical to our onJump function. So if we're not pressing our controller key down, we return. Otherwise, we toggle our walk boolean by setting it equal to not walk toggled, the opposite of its current value. Now let's implement our walk logic in the player controller. We'll add a walk acceleration and walk speed variable, then we can navigate to our update movement state function. This is going to be pretty easy. We just need to add in a new bool is walking, which is true if we are moving laterally and we're allowed to run, which I'll store in this boolean variable can run. We haven't made can run yet, so let's put this up at the top, and we could just do this where we set it equal to the expression the y component of our movement input is greater than or equal to the absolute value of our player movement's input in the x direction. But I'm actually going to make a separate function for this called can run. The reason being, I may want to add to this function later on, and I want to give it a little comment here so it's a little more clear what's actually happening. Basically, what this statement means is we need to be running forward at a 45-degree angle or less for us to be allowed to run. Otherwise, we're either strafing or moving backwards. The reason that we're doing it this way is that we want to reduce our speed to our walk speed if we aren't moving in the forward direction. All right, so let's go back to our update movement state, and we'll instead set our boolean can run to the return value of the can run function. There's one more condition to add to determine if we're walking. So if we've explicitly toggled walk on, we are also in the walking state, which is determined by our player inputs walk toggled on boolean. Finally, let's add in our lateral state logic. We'll add in if we're walking, then we set the player movement state to walking. Otherwise, we do our previous logic. Okay, now let's go into our update lateral movement function, and we're gonna make just a couple easy changes here. Add in a reference for is walking by checking our player movement state, then add to our lateral accelerations ternary statement with is walking, then set to walk acceleration. Otherwise, we perform our previous logic. Then we do the same thing with our lateral magnitude, except we set it to walk speed. I'm also just gonna quickly adjust some default speeds up at the top to better match what I want. Then that should be it, so let's go into play mode. So I'm toggling the walk state with control. You can see our player state is in fact displaying correctly. And if we strafe or move backwards, we move at a greatly reduced speed as we wanted. Obviously, we haven't added in the walk animation yet, but let's do that now. So go into the animator, we'll click into our locomotion blend tree, and unfortunately, I'm gonna do another refactor here. I wanna add in idle and walk blend trees to our parent locomotion blend tree. So click on that, then add 2 new blend trees into the motions. We'll name the first one idle and the second one walk. For idle, it's real simple, real easy. We just add in 1 motion and drag in idle, then change our blend tree to freeform directional. Then we do have to remember to also switch the input parameters to input X and input Y. We'll do the same for our walk blend tree. Then I'll add in an idle motion and a bunch of others. So we want every animation that plays with the walk speed to be in this blend tree now. I'll fast forward a bit, but this is going to include walk, run backwards left, run backwards right, strafe left, strafe right, and walk left and right as well. So we've done this before. I'll show you sped up what I'm doing, but we just got to enter in the correct values. So the diagonal values in this case are actually going to be 0.35, which is 0.5 divided by the square root of 2. So we only have a walk right animation, not a walk left. What we need is to drag in walk right animations twice, and for the walk left one, we're actually just going to have to check the mirror box, and that's it. You should end up with a ring of blue dots like I have here. Then next, we need to remove some of the animations from our run blend tree. We just want to keep idle, run forward, run left, and run white. That's it, so remove all the other ones. Then the final thing we need is to update our parent blend trees values. So click on that and we can make idle 0, walk 0.5, run to 1, and sprint to 1.5. That means that we're gonna have to make one little change in our animation script, so navigate there, and we're gonna just add into our input target another ternary statement. So just add in the is running on the second line, then a colon at the end, and if we're not sprinting or running, that means that we're walking, so we now multiply by 0.5 here. In play mode, we should now see that our walking animation is working and we can blend into run and sprint as needed. I will say though, this walk animation looks like kind of like an army man walking way too fast and rigid, so we can improve this a bit pretty easily. If we just head back into the blend tree, there's actually a speed parameter. If we simply set our 3 walk animations to 0.75, that means we're going to reduce the speed of the animation, and back in play mode, you can now see things look quite a bit better. So this is something that is always really handy when you're importing animations from other sources and you want to change them up. Okay, so we've reached the end of this tutorial, so let's check out the demo. This was a really tough one. If you watched this all the way through, I hope you learned a lot. And at this point, we have a player who can smoothly blend between running, sprinting, and walking animations. We've implemented strafing, and we even have a turn left and right animation when we're idling when we turn our camera direction. This tutorial has been a ton of work for me, so just remember I do always release all of my work completely for free, but if you are able to spare just even the lowest tier membership on my Patreon or YouTube member, it would really help me a ton in continuing to bring you guys free tutorials in the future. Alright, I hope you guys are still enjoying this tutorial series. I will see you in the next one. Peace!